Anxiety is a disorder that affects 40 million adults in the United States, according to the Anxiety and Depression Association of America. Science has tried to study in depth the biological and social effects of anxious individuals in the last decades. We wanted to study the effects of anxiety on a famous test that would help determine if anxious people would take a longer time to respond to a shown stimulus. This is the Stroop task. The Stroop task is an experiment composed of 40 rounds of stimuli presented with the help of a computer, where participants are asked to differentiate between the congruency of a color and the color itself presented on the screen. In this test, one of 4 words, including red, blue, yellow, and green, will appear on the screen in one of those 4 colors. The participant must identify the color of the word presented regardless of what the word is. We hypothesized this neuropsychological phenomenon would cause anxious people to have longer reaction times when it came to the overall result of the test. We developed a between-subjects experiment that consisted of answering 6 anxiety-related questions to see where they scored in regards to generalized anxiety disorder. We also included gender, age, employment, and ethnicity questions to better identify our participants for future research. An example of a question looks like this. Developed by Spitzer, Kroenke, Williams, and Lowe, found on the SciToolKit database. The survey was followed by the actual experiment where participants responded to the stimuli shown by the Stroop task. The survey and the experiment took an average of less than 5 minutes to complete. Our sample consisted of 50 participants, however 19 were dropped from the database because the survey and/or the experiment were left unfinished. We tested our hypothesis with a 2-sample t-test that used the overall reaction time and the congruence versus incongruent variables. A p-value below the alpha level of 0.05 suggests that our data has a statistically significant correlation between our 2 variables. The p-value also suggests that we reject the null hypothesis, which states that the difference between the average reaction time within our high and low anxiety levels will equal 0. This means that we accept our alternative hypothesis that there will be a difference between the average reaction times for both levels. This is shown in the graph. This graph shows the average time between participants who reported low anxiety levels and those who reported high anxiety levels. The average overall reaction time between low anxiety individuals is 300 milliseconds, while the high anxiety individuals was 90 milliseconds. Results contradicted our original hypothesis that people with higher levels of anxiety would actually have slower response times, and instead it concluded a statistically significant relationship between high anxiety levels and faster response times. We believe this could possibly be due to the anxiety that occurs through the stress of submitting a response before a timeout message pops up on the screen.